Queues. This video is going to talk about another very commonly used and useful data structure called the queues. You're going to see some similarities between these queues and a different data structure called the stacks. If you haven't watched the video on the stacks, I encourage you to do so at any given time and then compare the two data structures. So a queue is what we know as a FIFO data structure. FIFO means first item in is the first out. FI, first in, is the first out. FO, FIFO. And that means essentially that the first item that we add to our collection is the first item that is going to be removed or deleted from the collection. So typically, a queue is nothing else but a representation of a line in real life. And as we know, lines normally behave that way, meaning, any person that is being added to the line is added at the end of the line, and the first person to leave the line, the first person to be taken care of, is the person at the front of the line. But at the front of the line means that was the first person that joined the line. So the first item in, the first person that joined the line, is the first person to leave the line first out. First in, first out. Other examples are computer jobs to be processed, right? They are in an order, in a sequential order. They are in a line. Think about your code is executed most of the time sequentially, one line at a time, one instruction at a time. When you open your email on a daily basis, you see that those messages are displayed in the order that they arrive. Typically, the first email that was sent is maybe at the top, and the last email that was read is at the bottom of what you see on the screen. So there is some of like a line behavior. And again, there are many things in computer science and in real life that behave as a line, as a FIFO, first in, first out. As a reminder, we studied something in stacks called LIFO, last in, first out. So this is a different data structure. A difference between this, queues and stacks, is that the insertions and deletions take place at opposite ends. What does it mean? Well, again, people leave a line at the front of the line and people join the line at the end of the line. So the insertions happens at the end, the deletions happens at the front of the line. They take at opposite ends of the collection, right? So we add at the end of the queue, we remove from the front of the queue. So notice that we're talking about position. Who is the last one in the line? Who is the first one in the line? Okay, and pretty much we don't care about anything else in between. And also we don't care about values. So queues, likewise stacks, organize data by position. Okay, again, who is the last element on the line? Who is the first element of the line? We're not talking about values, but those two positions. And we don't care essentially about anything else. So stacks and queues are two data structures that are used to organize our collections of values by position, not by values. So in generally, we don't talk about sorting or alphabetizing queues because that is not relevant. Okay, let's talk about typical operations on a queue. Well, of course, we are going to implement it somehow. We'll talk about this in a couple of minutes. So we need to initialize the queue and to signal that the queue is empty. Nobody has joined the line. There are no values in the line. And then, of course, we need to have a way to add values and to delete values. But because, again, we're talking about a queue, those are very specific operations that we're going to discuss in a couple of minutes. And in addition, they have very specific names. The method add is called enqueue, and the method delete is called dequeue. So when we talk about enqueue and dequeue method, it's understood that we're talking about a queue. Again, when you watch the video with the stacks, you're going to see that there is something called push and something called pop, and those are the add and delete for the stacks, and that means also we're dealing with a stack. Another thing that is important to know, and it depends on kind of representation we have, is how many elements we have on the queue, because at any given time the queue could be empty or could be full, and those are two very important states of our data when we deal with the queue. In addition, we can ask questions about the status of the data in the queue. For example, is it empty or is it full? And that's very important, and there are two to know, and there are two very different states. Okay, the line is empty, the line is full, means different thing. And then we have a method pick, and if you did the lecture on stacks, you're going to see that there is also a method called pick. So The four methods basically when we talk about queues are enqueue, dequeue, isEmpty, and pick. So let's talk a little bit more about those four methods. Okay, so here we have enqueue, right? So enqueue is the method to add values to the queue, the method to add values to the line. And as in any other line, the new objects are inserted at the end of the queue, at the end of the line. It's a void method most of the time, although it could be implemented in a different way. And obviously, it needs to take one parameter, which is the new object that we're going to insert. The queue is the method that we use to remove a value from the queue. But very specifically, we remove the value that is at the front of the queue. We remove the first person at the beginning of the line, right, as expected. And then this method returns the value that is being removed. Again, very important to notice that there are no parameters for the remove. Most of the time, when we remove, we ask which value is being removed, which is the value of the object to be removed, or we add which location do we want to remove a value from. And notice here that neither of those two, neither the location nor the value, are being asked because it's understood that the only thing that we can remove is the first item in the line, the item at the front of the queue. Pick is similar to the queue in the sense that it returns the value at the front of the queue, but it doesn't modify the queue. In other words, it doesn't delete. So it's important to know sometimes what is the value of the element at the front of the line. And finally, we could have isEmpty, and also we could have isFull, and those are typically Boolean methods. And isEmpty is going to return true if the queue is empty, false otherwise. And if we would have isFull, it would be very simple to come up with the specifications for that. Before I start talking about implementations, let me tell you that if you go to the Java API and you look under queue, you're going to see that there is an interface queue. Now, this interface queue normally is not used because the implementations for a queue can be very, very different from each other, so there is not a consensus on how to implement the queue. The consensus is that it should be a FIFO data structure, in other words, the first in, first out, and that we're going to have some sort of enqueue, dequeue, and pick. So if you're curious, you could go to the Java API and look at the interface queue, but you're going to see that normally we don't use interface. There is an agreement on how these four methods, enqueue, dequeue, pick, and isEmpty, should behave, but that's left to the person who does the implementation. So in general, the user provides their own implementation using the tacit agreements for the four methods we just discussed. Typically, the two basic options are you are either going to use an array that has indexes or you're going to use some linked list that provides references. So if we use an array base, and again, when we initialize, we're going to have to specify a size. So at the beginning, the queue is going to have a very fixed size. And it's important then to know whether or not the queue is full because we cannot add more elements and then we need to do something. It uses what is called a circular array. In other words, we're going to wrap around. Okay, so if we are adding and deleting enqueuing and dequeuing elements and we reach the last index possible in the array that we created, we don't stop there. We sort of like wrap around and start using the indices at the beginning of the array. So think about a donut-shaped array in which the first element is connected to the last element. So there is a donut, those are the elements with a hole in between. So the indexes are the same. They start at 0 to a certain size minus 1, but now we don't limit the indexes to be less than the size minus 1. We keep like rotating the indices. But at one point, we are going to have a full queue. Because of that, it's important then to know, because we have a circular array and the indexes are rotating, let's say clockwise, we need to have then two integers value. One that tells us, oh, this index represents the front of the queue, that's where we're going to delete from. This second index represents the back of the queue, this is where we are going to insert to. And again, there has to be some relationship that we are going to study in a different video between the values of the front and the back. There has to be a way that by looking at this value, we can differentiate or establish when the queue is full or when the queue is empty. And that's why we need those two indexes. And in addition, because again, we're dealing with an array, we need to know at any given time the numbers of elements that also could help us to determine the state, whether or not the queue is full. I encourage you to look at a different video called My Array Queue, and that basically is an implementation of a queue using an array. And then you're going to see how the circular array works and how do we use front and back and the numbers of elements to differentiate between the different states of the data within the queue. On the other hand, we could use references, which means we're going to use basically a linked list, okay? So now we don't have a fixed size because linked lists can grow and shrink dynamically. And what we do is to have two references. Typically, on a linked list, we have a reference to just the beginning, what is called the front. But because we're talking about a queue, right? Operations happen at opposite ends. We need also to know the back. So we need a similar reference to front, but it's going to be looking at the back of the queue. There is another video called My Linked Queue, which discusses the implementation of a queue using a linked list. So I encourage you to watch this video and watch the video with My Array Queue, and then actually watch the videos on the stack class. There are 3 videos, and then compare the efficiency of queue versus stacks.